All right, you guys, we're going to do two-way tables again. We did these actually in chapter 2. All right, two-way tables to model a chance process and calculate probabilities involving two events. And then we're going to apply the general addition rule to calculate probabilities. So yesterday we just straight up added things together, like what's the probability of rolling a 1 on a dice or a 2 on a dice. Since those events were mutually exclusive, you could just do 1, 6 plus 1, 6, right? There was no overlap. They did not occur at the same time. Today, though, we're going to talk about what we do if events are not mutually exclusive, which if you have a two-way table and you're picking one thing that goes across and one thing that goes down, they're not going to be mutually exclusive. There will be overlap in your two-way table. All right. Students in a college statistics class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on two variables, gender and whether or not the student had a pierced ear for all 178 people in the class. Here we have our two-way table. Suppose we choose a student from the class at random. Define event A as getting a male student and event B as getting a student with a pierced ear. What is the probability of B, or the probability of someone having a pierced ear? Raise your hand if you could tell me the answer to that. Catalina? Yep. So here we have pierced ear, yes, no. There's 103 people out of 178 that have pierced ears. Boom. All right, it's just reading the table, okay? Now, find the probability of A and B and interpret what this means in context. So we are going to do and today, meaning both, all right? Means both. So it's like find the probability of A, meaning is a male, and B has pierced ears. Okay, what's probability of being both a male and having pierced ears? That's what the and means today. Okay, male and pierced ears. Raise your hand if you could tell me that probability. Whitney? Yes. Do it out of everybody, all right? When we do conditional probabilities, which we will get to, that would be just out of the males if you said 19 out of 90, okay? But out of everybody, so this is the probability of being both male and having pierced ears out of everyone. There are 19 out of 178 males with pierced ears, okay? Interpret in context, you guys, just both, being both male and having pierced ears, all right? Okay, now we're going to do or. Find the probability of A or B. So what does or mean in statistics? Okay, it's going to mean add, all right? So probability of A is probability of being a male, all right? Go ahead. What's probability of being male again? Or I guess we haven't done this one yet. What's probability of being male? Okay, 90. There are 90 out of 178, okay? And we would add that to the pierced ears, all right? B stands for pierced ears. What's the probability of having pierced ears? Now, can I add these together and is that the correct answer? No, because who did I just double count? Yeah, I counted the 90 total males and the 103 with pierced ears. However, I just counted those 19 people twice, right? Because it is not, I know, oh no, it is not mutually exclusive. So if it's not mutually exclusive, you're still going to add the events, but you will subtract the overlap. All right, so whatever that answer is over 178 would be your answer. So here's what your formula is. This is called the general addition rule for two events. It is super important. Even if you think this is easy, I would write it down, okay? So if they ask you to find the probability of A or B, think add, right? I'm going to add the probability of A plus the probability of B minus the probability of A and B, which is this whole like both at the same time thing. That's what you're thinking of, all right? Both at the same time. Now, yesterday, you guys, if two events are mutually exclusive, if they are mutually exclusive, what is this piece equal to? We wrote this down in our notes yesterday. Okay, so in other words, if I said, what's the probability of rolling a 1 or a 2 on a dice, you would just be like 1 6 plus 1 6, and there's no overlap, right? You either roll a 1 or a 2. You cannot roll both at the same time, all right? So you just add the probabilities because this piece here is 0. But if you're doing a two-way table and you have one thing, one of your variables that goes across and another one that goes down, you're going to have overlap where you double counted people, and you're going to want to subtract that, all right? You will be given a formula sheet for this test as well as the AP exam. This formula is on the exam, but it looks like this. You do want to know these symbols. I don't know if you guys remember these from the green book. You guys are like, okay. This means union, which means add, which means or. All right. It's like the same thing. I just use words here. Okay. All right. And this little symbol here, the upside down U, that's intersect, which is the and part, or both at the same time, okay? Or if you want to think of it as the overlap. Get used to these symbols, okay, because you will see them, so practice using them. All right, Facebook versus Instagram. A survey of all residents in a large apartment complex reveals that 68% use Facebook, 28% use Instagram, and 25% do both. Suppose we select a resident at random. What's the probability the person uses Facebook or uses Instagram? So we're going to write the formula first, all right? Probability of Facebook or Instagram. Okay, and again, practice that lovely symbol. Okay, Facebook or Instagram. That means we add, well, what's probability of who uses Facebook plus what's probability of who uses Instagram? And we have to subtract the people we just double counted because some people like social media and use both. Okay, so what do I plug in for Facebook? 68%. What do I plug in for Instagram? 28%. What should I subtract? 25%. Everybody good? Easy peasy? All right. Okay, you guys remember cards, right? Everybody remembers cards. We went over it yesterday. There's like 13 in a suit, right? We go from ace all the way up to a king. All right, we've got these 3 that are called face cards. Remember that? Jack, queen, king, those are face cards. All right, so here's our 2 events. F is going to be face card, getting face card, and H is going to be getting a heart. Make a two-way table that displays the sample space. This reminds me of Mr. Carlson. He taught me those ratio boxes back in pre-algebra. All right, so we're going to make this all together. You guys do this with me. See if I did enough. All right. On one side here, we want face card, not a face card, and total at the bottom. I'm going to move. Oh, yeah, that'll work. Okay, I'll move that out of the way. All right, total. Okay, and at the top is our other event, which is hearts. Okay, and you can go your variables on either side. Doesn't matter which way you do it. So I'm going to do hearts, not a heart, and total. All right, so right here is my total. How many total cards are in a deck? All right, so I know 52 goes here. Okay. And down here in this lovely box, this means total hearts. How many total hearts do we have? 13. Okay. And this box here means total of the face cards. Ace is not a face card. It's a jack. Yeah, there's 12. Queen and a king, right? So there's 3 in each suit, right? So there's 12. There's 3 from each suit. So we got 12 face cards total. Okay. And we can also fill in this box right here, face cards that are hearts. There you go, 3. There's only a jack, a queen, and a king of hearts, okay? And then we can fill in like what's missing. So for example, I have to be able to add down. If there are 12 face cards, then this has to add to 52. So there's 40 not face cards, okay? And if there are 13 hearts, how many are not hearts? 39, because you got to add to 52, okay? Or think of this as 3 times 13, because there's 3 other suits with 13 each, okay? All right, and then of the hearts, I've got 3 that are face card. What goes here? 10 that are not face cards. That's the ace through the 10, okay? And then going this way, this has to add across, right? So this would be a 9 to give you 12. And this would have to add across or down, so that'd be a 30. Okay, once you do your box, now we can answer some questions. So we made a two-way table displaying the sample space. All right. And let's see what this says. Find the probability of F and H. All right, so F and H means both at the same time. So what's probability of being a face card and a heart? Raise your hand if you can tell me the answer. Eric? There you go, 3 out of 52. Okay, 3 out of 52. All right. Explain why the probability of being a face card or a heart does not equal just the probability of face card plus the probability of heart. How come I cannot just add the 2 together? Yeah, I would have counted the 3 twice. Okay, there's overlap. You can be both at the same time. They are not mutually exclusive. Okay, you can only use that formula if they're mutually exclusive. Then it says use the general addition rule to actually calculate. Okay, this is where I would like to see a little bit of work, even if this is easy for you. Okay, so this is the OR problem. All right, we know they're not mutually exclusive, so use the little formula. We're going to add the face cards plus the hearts, and we are going to subtract the and part, the both at the same time part. Okay, so what's the probability of being a face card? What's probability of being a heart? Yep. And then subtract the both at the same time. That's a 3 out of 52. So 25 minus 3 is 22 out of 52. Okay, so show your work for each thing, what you're adding. All right, you guys, there are 4 homework problems. We are going to do this lovely 5.2b worksheet, and we'll go over it. All right, probability that the student scored a 3 or better. So be sure you say what you're finding the probability of. 3 or better would be this, which is 0.578. Okay, probably that the student chosen did not get a 1, so you need to do 1 minus this, or I suppose you could add all 4 of those up, okay, and you get 0.764. You could also write this with like the complement symbol, right? Probability of not a 1. Good job. Okay. Here we have our two-way table, which can go the wins on either side, tacos on either side. So probability of just winning, you guys, this out of this. That's probability of winning. Okay. Probability of winning and free tacos. Again, practice using the and symbol and make sure you know what it means. Okay. And is both at the same time. Win and free tacos is 26 out of 81. All right. Probability that they win or there are free tacos. I would like to see the general addition rule, right? So here's my or symbol, win or free tacos. Okay, so win is 41 out of 81. Free tacos is 30 out of 81, but I double counted the 26 out of 81. So I get 45 out of 81 as my final answer. Always show these 3 things. Even the formula is good to practice. Okay, here's the formula. That's what it's asking. What is the general addition rule? Okay, is it on the formula sheet? Yes. Yes. All right. What if the events are mutually exclusive? If the events are mutually exclusive, what is this overlap equal to? It means there's no overlap. So you can just add the events. If they are mutually exclusive, you don't have to subtract anything. All right. If you have a two-way table, they're probably not mutually exclusive. All right. Make sure your name is on that. When you're done, pass it over.